Hey, what's going on, folks? It's Mike here, and welcome to my software design series in C++, where we're going to continue talking about the observer pattern. So this is the next lesson in our series. Please make sure to watch the previous lessons if you haven't, so you can see what we've been building up to. Now, in this implementation, we are going to add a little bit more power to our subject this time in the observer pattern. But before I get to that, and before we start writing some code, let's go ahead and review what we did in the previous part before we talk about our fourth implementation. So previously in our main, the goal was, and the big innovation that we created here, was this idea that for our subject, well, we could have each of our observers, which I'm just calling watchers here, directly subscribe when we create them to the subject. And then their lifetime could actually be managed automatically. So if you have cases like this where you have a watcher that might go out of scope, whenever we notify, then we don't have any problems with, well, what happens to watcher 3? It's automatically removed itself when it goes out of scope using the RAII principle. So again, just to review this, here's what our code looks like. Let's go ahead and look at that observer code here, the CPP file, where again, we can see from that little demo that I did in our previous lesson, where our watchers are automatically adding themselves and removing themselves in the constructor and the destructor respectively. So that was the big innovation from last time, and that gave us a little bit more power in how easy it is to maintain our objects. Now we do have to do a little bit of work in the sense that we're doing this for our concrete implementation here if we want this functionality. And we just have to keep track of our subject here. So that was the basic idea. But for today, let's go ahead and take a look at our fourth round of the observer pattern, this time giving our subject a little bit more power with how it's working. So again, sometimes we want to be a little bit more specific with the type of tasks that we are trying to achieve here, meaning that if we have a subject of great importance, say the main character in a video game, the main character might have sound events, physics events, and graphics events, and even more, trigger events, and whatever else in the subsystem that you want that character to respond to. So it might not be necessary for us to notify all of our observers every time something interesting happens to our subject. So that's the improvement that we're going to build in this time. So the basic idea, and I'll move out of here, is again to see that each of our observers here, observer 1, observer 2, and observer 3, might belong to different subsystems here, like the logging system, the physics system, the sound system, and so on. So that idea then is that we could, if we wanted, create different classes for each of the sound, physics, and the log classes as needed. Or we could even have multiple physics, say, observers here, but we just want the ability to maybe notify a specific subset of them. Either way, that's the idea with the power that we want to be able to add into this system here. So we're going to see right above me here is that our subject is now able to keep track of sound system events, physics, system, log, etc., and be able to notify specific observers that belong to these systems. So that's the idea. I'll move out of here one more time. And here's what we're going to do for our implementation. So our subject is going to need some way to keep track of the different observer types. Now, the easiest way to do this, or at least the first that comes to mind, would be to use some sort of map data structure. So again, I'm going to use a map here, and we'll have a key be some sort of integer type here, and then we'll have each of our observer lists depending on if that observer is part of, say, a physics system, sound system, etc. That's how we'll keep track of things. So we'll have our observers map. Now, for the aficionados out there, or for those folks watching my C++ series, you could also use an unordered map if you want. It just depends on how important the ordering is here, what properties need to be preserved. So feel free to change this as you need. All right, so here's just an example of this data structure. Here is what we are creating here. Again, the keys are going to be our sound system, physics system, log, etc. These are the different categories or different ways to bucket each of the observers as they subscribe here, so that only a subset of our observers are notified, even though we might have lots and lots and lots of observers subscribed to the same subject. So that's the idea, and that's the data structure going forward here. All right, and then as far as how to keep track of these different message types or the individual bins, again, I'm using an example of a game character here where we might have sound, physics, and logging. So if I go back just for a moment here, again, you'll see sound, physics, and the log at the top as our individual keys. I'm just going to make this simple and just create an enum inside of our subject, and these will be the different types of events. Again, you can go ahead and see that we probably want to do something like an enum class to give this a little bit more power and type safety. Feel free to improve on that in this implementation. But as you're learning, start with this, get it working, and then incrementally improve a little bit here. Okay, and of course we could add even more functionality here and flexibility by not just having a enum that we would have to recompile, because maybe at runtime we want to be able to add different types of observers. So you could imagine some sort of type here for our message types, and maybe this is a vector of strings, and you just sort of use that as a very simple and dynamic way to create different types. Or more simply, a vector of integers, and then you could map those to strings or whatever for performance and so on. Again, I'll give you the option to optimize this as you need later, but for now, if you're just learning observer pattern, just go ahead and create in your concrete subject the different types of message types that you'd like to be able to subscribe to. All right, so with that said, then here's what our AddObserver will be modified to, where we'll just have to add the message or the bucket that we want an observer to fall into. Again, int message here, just being an enum, could be something like a sound, a physics event, a log event, etc., etc. So that's the idea. So then we'll add our observers to the specific list for that particular key that it belongs to or the message type, and then only push out messages to specific observers if we like. Okay, and then we'll have, beyond having just notify all, we'll have notify and then a specific subsystem that we want to notify. So that's the implementation. Let's go ahead in our code and let's go ahead and step by step build this up here. So what I'm going to go ahead and do is switch to our terminal and let's begin. So again, I'm going to start this off by just looking at our particular subject here. Let's go ahead and look at the interface that we have here. Subject, HPP, and this is where I'm going to go ahead and put the enumeration here. So what I'm going to go ahead and do, and I'm going to do this in the concrete type. Again, we probably want to separate this out into its own file, something like some subject.hpp. Again, I'll let you refactor that later, but I'm going to keep this relatively simple so you can see all the code here. But I want to put the enum in here. And again, there's different places that you could place this, meaning you could have some sort of message type data structure. Maybe you could put this in your interface if you know you have sort of a uniform set of messages that you want to apply, but I'm going to go ahead and just put this into some subject because these will be particular messages for any type of some subject here. So let's go ahead and put in the message types here, and I'm going to use the same subsystems, stuff like playing a sound, handle physics, and log. Let's just go ahead and start with 3 for now, just to make things nice and simple. So let's now go ahead and modify this structure here. So we're still going to want our list of observers here, or this forward list here. Okay, so that's still going to be useful for us here, but I'm actually just going to sort of structure our code here in a little bit of a different way here, in which I'm going to create this type def here, and we're just going to call this the observers list here, observers list. Let's go ahead and move this over here. And then I'll create another type def. This is going to be for our map. And again, this could be an unordered map or whatever data structure you decide. But for now, I'm just going to keep things simple. And let's go ahead and set up our observers list here. And I'll call this observers map. And again, I'm making this a type definition just so it'll be a little bit easier in our code for us to work with. Again, you might consider something, again, if you're using modern C++ style with the using keyword to equivalently put this in here. I have some lessons on that in my C++ series. All right, so let's go ahead and create our observers map here. And I'm just going to call it mObservers. And now we'll have to modify our AddObserver and our RemoveObserver so that they're now working with this data structure. So I'm just going to put this our key value pair. And it's always nice to label these things. Key is in int or enum in this simple demo, and the value is a forward list of our observers. And again, it can be any kind of observers. Remember that we're using this sort of base class here, or interface here, as I indicate with capital I here, to make this relatively simple. Okay, so let's just go ahead and leave that as is. And now let's go ahead into our implementation of the subject so that we're able to add observers and remove our observers as appropriate here. Okay, so let's go ahead and open up ISubject here, the actual implementation. And now this gets a little bit more interesting because since we have a map, we're first going to want to find and see if where our bucket is. So I'm going to just go ahead and create an iterator. This is a good use of auto, in my opinion here. And this is from our observers. And we want to be able to find the message or the system, however you want to sort of label this, that we're updating. Now, what that means is I'm going to have to add a parameter here for our message. And again, this is going to be the enum. So I'll just say message is our enum for, you know, play sound, physics, event, I think I called it, and log, and those things there. Okay, so that's the basic idea here. Actually, I'll have to go back into, and let me just split this so you can see everything on this window here. Let's go ahead and bring ISubject, the header back, because I'll have to remove it from, change our function signature. There we are, so that we have it there. And likewise, we'll also have to modify our RemoveObserver to remove our observer. Now, we might want to even consider how we handle removing if we want to just iterate through the entirety of the map to make this a little bit of an easier interface. But we could consider that an observer could be part of both a physics and a logging event, for instance. So you might have to think a little bit about this design when we're removing observers. But I'm going to leave that up to you. That's just a little tiny detail for you to think about, or maybe a big detail depending on your system. But let's just go ahead and modify that as shown here. Okay, so now what we need to do, again, is to see, well, if I'm searching for our particular bucket, that means, so let's go ahead and add some comments. Search for our enum. So that's, again, play sound, physics event, log. That's what this is doing here. It's telling us, or the iterating through the map and saying, you know, where am I going to add things, which list here. So if our iterator equals the end here, that means we effectively didn't find it. So we need to create this bucket here. So observers, and let's go ahead and set the message equal to, well, I'll go ahead and make it equal to our observer list, something like that. So we need to construct a new forward list here. And then what I'm going to want to do here, regardless of the situation, so whether I am creating this new bucket here, so again, if we didn't find this first event that was added, then I'm going to need to add this message. So in our observers here, I just call this observers in the particular bucket. Then we'll want to push to the front of its list the appropriate observer. Now, for our remove here, we'll essentially have to do the same thing, where we search through our observer list, see if we actually find the particular message that we want, and then we'll have to iterate through that list to see if we find the observer, and then effectively call list.remove on this. I might leave that towards the end if we have time, but for now, let's just go ahead and see if I've made any silly compilation errors. So let's go ahead and compile this. Looks like I've made a few here. I'll need to include the map data structure. So let's go ahead and make sure that we include that here. So now that we have our map, let's go ahead and just tackle these sort of one at a time here. And it looks like the rest of these errors are popping up in our actual main where we are setting this up. So let's see here, ISubject and our HPP. Okay, let's see here. Yep, just looks like so far we'll just need to modify anywhere where we're adding an observer here. And that's also going to include in our actual observer class here. So let's start getting that ready here. So I'm going to open up IObserver. Let's open up the CPP file. And let's go ahead and open up the header file below here. So for our observer now, one way to handle this, and let me go ahead and close this down for a moment, is in our concrete implementation here, we could either do one of two things. I could either create a sound watcher or a sort of physics event, as I showed, or a sound event. Or for my watcher, I could choose the subject that I'm subscribing to and the particular system in one function, and then any other parameters that we need. That's what I'm going to actually opt for here, just to make this a little bit simpler here. So we'll choose the subject, and then we will choose which system that we want to subscribe to. So I'm just going to put in this again as an int for our message that we want to set up here. And let's go ahead and do this here, int message. Now, this is just a sort of a C++ thing, but you might also consider making this message as the last parameter and then maybe creating a default argument, setting this to 0 or something. So if the user forgets this, or you just don't want them to choose or don't care or don't have any system set up, that could be something that you again think about. Just depends on how you're setting this up. Because what we've done is, again, because we're requiring for our watchers to subscribe immediately to a subject for a little bit of safety on the lifetime, that's something we've defaulted into. And then again, we might want to do, again, further setup or, rearrange these arguments as needed. So anyways, let's go ahead and we'll just set this up in our initializer list here. Now our initializer list is getting a little bit long, so depending on your style, you might move this on a different line here. I'm going to do this just for indentation's sake. Actually, we don't need to really keep track of which system the watcher is part of. I'm just going to directly add this to our observer. So let's just go ahead and say who we are subscribing to on the message type here. Okay, so that'll do the trick here. And then when we remove our observer, I believe I also added that here. So this will be the message here. Okay, so let me just check this. This looks good. We now are able to pass in a system here. And let me go ahead and just look at our signature for ISubject, the header file. And we are removing, oh, I guess I mixed these up here. Let me go ahead and switch these. I guess it doesn't really matter here. Let me just make sure I call these in the right order. So go ahead and say the message and our subject. Again, that's maybe not as consistent as I'd like, but let's go ahead and get this running here and see what happens here. Okay, so let's go ahead and look at our observer, HPP, just to make sure that this all matches here. Again, we've got our subject, our message. Yeah, this looks pretty good to me. So let's go ahead and close this down for a moment. And let's go ahead and look at our main for how we'll actually set this up. And now for each of our watchers, we have the subject that we're subscribing to, and then we need to pass in a enumeration. So that's coming from some subject. And then we need to, let's see if my autocomplete's smart enough to find it. I don't see it in here, but let's go ahead and do like play sound. Oh, there it is. Okay, so that's what it'll look like to create each of our observers. And let's go ahead and try this out here in a moment. Let's just do everything in two things in sound, some subject, play sound. All right, and then we will modify our NotifyAll here to make sure that we are in fact iterating through our entire map here. That was the one thing that I forgot, so I'll add that here. And that's in our subject. And let's go ahead and take care of NotifyAll here. So for this, let me just go ahead and rewrite this. Actually, let's see. Let me give this a try here. And let's go ahead and clean up this here. So what we're going to need to do in order to iterate through our map here is basically get an iterator to our observer map here. Let's get the iterator, it. And, well, we want that to be from the beginning of our observer's map. And I'm going to kind of separate this out on a separate line here. And we would say something like, well, it is not equal to mobservers.end. And then we want to move this forward. Okay, so that's the for loop here. Look through all of our keys here. And then let me grab this loop here, paste it in. And then now what we want to do here is for each of our observers here that we are grabbing, what I'm going to be doing is, because this is grabbing the key here, our iterator, and to get the key from a map, we're looking at the first entry here. So you can look again, depending on how you've sort of set up your map here. This is likely what you're going to want to do here. And this should do the trick here. Let's go ahead and give this a compile. Oops, looks like I have a error here on some other file. IObserver CPP. Let's go ahead and make sure that we fix at line 9. RemoveObserver. Let's see here. This looks like in our watcher. Let's go ahead and look at our header file for our watcher. Make sure that I updated the actual subject, or maybe this isn't our subject. Sorry about that. Let's see here. AddObserver. And okay, when we are removing observer, we're taking the message here. Okay. And let's make sure that I match that in our header file. When we are removing, yeah, that looks okay to me. Let's see here. Ah, I see what the issue is here. In our actual, so it looks like we are going to actually want to store this message here, because in our destructor, we'll want to remove the particular message here. So let's actually keep track of this. Okay, so we'll have to do just a tiny bit of tiny refactor here. Let me go ahead and describe the issue to you in a moment here. Let's go ahead and open up our observer interface, and let's keep track of the message that we are part of here. So let's go ahead and set that up here. And let's see, I should be consistent here with how these parameters are laid out here. So let's go ahead and say message. And that way in our destructor, we can just pass in message here, message. This is just going to be message, message. And there we go. And we need to have these in the right order. So message takes in message. Okay, there we are. Let's go ahead and give this a try now. Oops. If I compile, let's see if I made any other silly errors. None so far, so that's good news. Now let's go ahead and see how this works, and then hopefully we'll be able to do a code review, and then I'll tell you what's left for implementation here. So let's go ahead and do our main. And we're putting these all in the sound system, and let's just go ahead and see if we can notify all of them. Okay, so I will compile one more time just for good measure. Let's go ahead and give this a run here. And it looks like, well, I am going to need to update that remove here, because this is still crashing. We aren't able to remove our observer yet. So if I comment this out, I suspect this will work with it too. And that's working perfectly here. Okay, so let's actually go ahead and do some of the heavy lifting and implement in our AddObserver CPP, or rather our subject here, where we're removing the observer here. Okay, so let's go ahead and actually handle this case here. So let's go ahead and open our subject, and this will be nice because then we'll have this complete implementation, and then we can do the notify as well. Okay, so let's go ahead and handle one thing at a time here and do our remove observer. So again, this pattern is going to look pretty similar to what we have when we are adding things, what we're going to have is an iterator here. Look through all of our observers, try to find the bucket where our message exists here. And then we're going to say, well, if it is not equal to the end, that means that we must have found a bucket where things exist. So we found the right bucket, or i.e. key, and now we just have to iterate through the list here. Okay, so there's a couple ways that we can do this. I'm just going to take advantage of our observer list. I'll create a reference here just to make things a little bit easier, and let's go ahead and say, okay, where's the message here that we have here, or rather, this is the so now iterate through our list here. Okay. Oops. Let's go ahead and center around here just so you can see what's going on. And then we'll just say for our observer list, let's get a iterator. Let's start from the beginning. And then we'll say something like, I'll just call this, actually I don't want to use IT, so li is fine. Li for our list does not equal the list.end. And then we'll just say if, and if I dereference this, whatever the object is that we find here in our list, if it's equal to the observer, then we can remove it. Okay, remove the particular observer that we found here. Okay, otherwise, we will increment. Okay, and we'll do ++li. Okay, so I think that should do the trick here for our remove. Let's go ahead and see if I made any compilation errors. Miraculously not. Okay, that's good. And then let's go ahead and open up our main here. Let's put our watcher back. Now let's go ahead and see if this actually removes. And it looks like this is now working here. Okay. So that might have been a little bit fast here. So let's go ahead and explain the code here for our remove here. That was back in our subject here, where we're removing our observer, just so you can see this. So again, the idea was to look in a particular bucket. And since our observers now are keeping track of which bucket that they belong to, this isn't too bad. The issue here with our current interface, and let me actually open this up, something for you to think about, is that a user can explicitly for the subject call AddObserver and RemoveObserver. So that also means the observer, or some user, if they were explicitly just adding and removing observers, they would have to keep track of this message somewhere. So again, you might either want to not allow this and make this a default bucket, or have some enum or something that's just a little bit cleaner here, depending on your use case. So just a little thing to think about there. Okay, so let me go back to the remove code. Again, just a brief code review here. Again, we are looking through all of our buckets, and we say, well, if we found a bucket of this message type, then let's look through the list. So that's what we're doing here. I'm just using the list here, this reference here, because it's just a little bit cleaner here for me to type out here for this list here, rather than doing observers of message, dot remove. I can just refer to this as list here. Okay, so just a little alias there. That's kind of nice. And then I'm just iterating through the entirety of my list from the beginning to the end. And if I find what I need to remove, I remove it. Okay, and then I keep moving my iterator forward. And of course, if I reach the end, then I terminate here and there are no observers to remove here. Okay. All right, so with that said, I know this video is getting long, but we're almost done, but we got to get to the main point here, which is to create a interface for us to just notify one message system. Okay, so let's go ahead and add this into our interface for our subject. And what we're going to have here instead of a NotifyAll is just a notify of a particular message. And we'll just call this notify. And just take a message type here. Now, again, this is where you'd probably want to have some enumeration. I'm just going to call this, for the sake here, message, to make things simple. Again, you probably want to use an enum class. Maybe if there's demand, I'll sort of modern C++ify this and use an enum class and make it a little bit better. That could be an option for a follow-on video. But let's go ahead and modify this here. So what I'll go ahead and do here is let's go ahead and implement notify. So this is part of our, again, this is part of our, just to show you the ISubject. So anything that is able to be part of this interface could be notified. Okay, that's the idea here. So void ISubject notify, and we take in a message. And now this implementation isn't too bad. We'll have another sort of for loop here and say for everything in our observer map, which we're calling observers, look through everything in that bucket and just call all those particular things notify. Okay, so that's the idea there. Let's go ahead and compile this, see if I made any silly mistakes. Nothing so far. Now let's go ahead and take advantage of this notify function here. So I'll go ahead and open up the main here. And let's go ahead and, well, let's keep all of our observers alive here for just a moment. And let's go ahead and add one to the log event system. And maybe to start, we will notify everyone. And then let's just go ahead and at the end, maybe just notify all the things that are part of the sum subject log system. So we should see watcher 1, 2, and 3 all print out on the first notify all. That's everything that is subscribed to this subject. And then when I just say subject, notify only the log, well, that'll just notify or watcher number 3 here. Okay, so let's go ahead and compile this. And fingers crossed, no bugs here. Go ahead and clear the screen and run this for you. And we can in fact see that this is working. So I see watcher 2, 1, and 3, which have been added here. And you'll notice that I'm getting this order of 2, 1, and 3 based off of our data structure here. So again, if you're using map versus unordered map, depending on how the buckets are hashed and things are stored, maybe you'll get some different behaviors, or if they're being appended or pushed to front or back. Again, that's just a note on that. And then finally, this last call here where I'm saying, hey, just notify the log events. I just get watcher 3. And just for a sanity check, since we've done all this hard work and we've made it this far, let's just go ahead and notify everything in our sound system for some event that happened here. So play sound. All right, and let's go ahead and compile. Let's go ahead and run. And now we see all of our sound watchers here. Okay, so that looks like it's working pretty nicely, and I think we'll go ahead and wrap up the video here. So folks, with that said, that's a full, or rather full, implementation of the observer pattern. There's still some stuff that we want to maybe make more modern with C++, things like enum classes and so on, but I'll leave that up to you to implement and add some details. Now, before we leave though, let's go ahead and think about some of the pros and cons. I can't leave you without discussing those, so let me bring this back up here and let me pause and let you think about this. And if you paused and thought about this for a little bit for our 4th implementation in this series, again, no pattern's perfect, but you know, we are getting quite flexible behavior here. This ability to notify all or just a specific subsystem is quite nice, how we've done this implementation. And you can kind of see from the concrete classes that we've implemented, some subject, for instance, and watcher, how much work is involved. In fact, by using the interface, it's not too much to have this functionality for notify all and just notify. Now we do have to think a little bit about what those actual subsystems are, so that might be the next step that you would want to take in, say, a game or a game engine to make this more flexible. Remember that you might want to actually make these message types or these specific subsystems some data structure that you could append to dynamically, if that makes sense. Now, is this data structure maintainable? Well, again, I'd say it still is, in the way that we're taking advantage of inheritance. By creating these base classes IObserver and ISubject, they are quite nice. Now we have some flexibility by using the standard template library as well for changing some things between map and unordered map if performance is an issue. So again, there are some nice properties there that we can use here. And of course, is this extensible? Well, in general, this is. And we've talked about some ways that we can add different message types. We can add different types of watchers that might have different behaviors on Notify. Is there some work that we have to do? Yes, of course, but it's overall a relatively extensible data structure, but there might still be maybe one layer of abstraction that you truly want to add on top of this. And again, I'm sort of thinking about this from a game engine perspective, as well as depending on how wild you want to get with this, you will start to have to think about some things when it comes to performance as well, and how we're iterating through these data structures, especially if you have lots of objects subscribing or lots of collisions going on. That's something that we haven't really talked about, but you could have in the instance of a game, an object that collides with another object, that collides with another object and triggers all sorts of events. So you do have to think a little bit about this pattern and maybe even add certain things like timeouts and sort of queuing the event handling and so on. But again, think about if you're building a really high performance system, if those things will matter. All right, folks, with there, though, I'll go ahead and end this. Again, thank you for taking the time to watch this video in this series. If you'd like, we'll look at some more maybe implementations of Observer, and maybe I'll go ahead and C++ify some of the code here with some of the things that I mentioned, like the enum class and so on, just to clean up the code. It might be nice to have yet another code review. So with that said, folks, thank you for your time and attention. Please leave some notes in the discussion if you have further thoughts. And make sure you subscribe if you enjoyed this series, and let me know what else you'd like to see. And with that said, though, thank you for your time and attention, and I'll look forward to seeing you in the next lesson.